At this point now, we are ready to load a pre-trained model. So here we have a Google Colabs form where we can choose a model. So there are some pre-trained model available, or you can upload your own checkpoint folder as a zip file. You can get your own model if you follow another tutorial by the guys from the Magenta team where they teach you how you can train your own model, and then you can use in this application. Let's see here what they are doing inside this. So here they have the Google form, the defining a find model directory, and this function will iterate through directories until model directory is found. Then here they are checking if you selected a pre-trained model or if you want to upload your own. If you select one of the pre-trained model, this pre-trained model is stored in somewhere in the cloud. They will create a directory. So at the moment we just have the sample data in the hand sound that I have here. So they will create this content pre-trained if you choose one of the pre-trained models, or content uploaded if you upload your own files. Then here is the location of the pre-trained models, and here they're using this Gsutil. So Gsutil is a Python application that lets you access cloud storage from the command line. So here are the instructions of how you can use it. They are using here, and they will have here also a gin file. It's all part of this structure, this file structures that they define here. So that the DSP models Timbre transfer, there is a date, then there will be the solo, the model that you choose here, checkpoint, the gin file will be operative config 0 gin. If you upload your own, it will be a zip file, so they will unzip here. They'll also get this gin file from the files that are inside this unzipped directory. Then they will load this data set statistics. We're going to take a look about this data set statistics later on. And what is interesting here is that they use this TensorFlow IO gfile exists gfile. And this function here, tfio gfile exists, determines whether a path exists or not. And there is some instruction on how you can use it. And they also using this gfile. So let's take a look what this is doing. So it's a file IO wrapper without thread locking. So the main roles of the tfio gfile mods are to provide an API that is close to Python's file IO objects, and to provide an implementation based on TensorFlow C++ file system. And there are also instructions here how you can use it. With this, they are loading this dataset statistics. Next, so now they have a gin file here, either if you uploaded or if you chose one model, and they need to parse the gin config. So for that, they are using this gin unlock config. Let's take a look at that. So it's a context manager that temporarily unlocks the config. Once the config has been locked by gin finalize, it can only be modified using this context manager. So they are unlocking config, and then they are parsing a config file. And we also will take a look in this function. In this parse gin config file, it takes as an argument a configuration file, the path to a gin config file. There is this skip unknown. This is a boolean indicating whether unknown configurables and imports should be skipped instead of causing errors. And it returns an instance of the parsed config file, includes and imports containing the final name of the parse files, a list of names of imported modules, and a list of the parsed config file includes and imports created from including nested gin files. So this is how they are parsing the information contained in the gin files. Then they will assume that there is only one checkpoint in the folder, and here will be this checkpoint. Next, they will ensure the dimensions and sampling rates are equal, and they will use this gin query parameter. So the gin query parameter returns the currently bound value to a specific binding key. So the binding key argument should look like something like this. You note that this will not include the default parameters, and it will return the value bound to the configurable parameter combination given in the bind key. So with this, they are getting time step string. So they are querying the parameter f0 loudness preprocessor time steps. And sample string, they are querying the parameter harmonic end samples. And the hop size, they are dividing the end sample string by the time step string. And they have the hop size. Then they are having here the time steps, which is audio.shape of this NumPy array divided by the hop size calculated here, and the end samples is the time steps times the hop size. And here you can print the time steps for the trained model and the time steps for the resynthesis. Well, let's uncomment this. So very interesting to see everything. And remember that this audio here is a NumPy array, and is what we loaded in a previous. We have here the audio that we uploaded. So we are at this point here. Then they will have a list of gin parameters. Once again, they will unlock the config and they will parse the config of this gin parameters. Here they will trim all the input vectors to the correct length. So they have for a key in this list, the audio features key, so one of these. Then we'll have audio features key, and it will trim to the time steps for these keys here. And for audio, it will trim to the number of samples. Next, it will set up the model just to predict audio given the new condition. And here it will build model by running a batch through it. So the model is this DDSP training models autoencoder. We are going to take a look at it in the next tutorial. Here it will restore the weights and the parameters for the model that was saved in this checkpoint. We also got this checkpoint earlier here. And then it will build the model by running a batch through it. You compute the time. So the model, it will have as an input the audio features, training set to false, and then it will tell us how long it took to restore the model. Notice that now, just for the sake of not using the GPU free time, I'm setting to no GPU, so it may take longer to build a model by running a batch through it. But let's run this. So we see here, we don't have any new files. Let's run the cell. Let's choose the violin. So let's see the form. It's the violin. Let's run the cell. Loading dataset statistics from content pre-trained dataset statistics. When we refresh here, we see that it created this pre-trained. Inside this pre-trained, we have this file here. We have the checkpoint.index. We have the dataset statistics.pickle, and we have the operative config gin. And it took 3.2 seconds. So now we have our pre-trained model loaded, and on the next tutorial we'll move on to investigate how does this model look like, what is the contents of this operative config gin, what is the content of this dataset statistics. And that's it for this tutorial, and I see you next time.